Welcome to an exhaustive chronicle of the voices behind the code, presented by the Computer History Museum Oral Histories. This collection goes beyond specifications, revealing the flesh and blood, the rivalries, philosophies, and accidental discoveries. These stories reconstruct the genealogy of innovation through the people who lived it, from the, quote, human computers of World War II to the visionaries of the web. We begin in the era of iron and vacuum tubes, focusing on the first programmers and operational pioneers. Jeanne Bartik, one of the ENIAC 6, helped to define programming, which meant physically routing cables, not typing code. Her team also acted as hardware debuggers, solving issues like bad tubes and machine logic. She later converted ENIAC to a stored program machine. Joe Thomson was the first operator of the MIT Whirlwind. He mastered troubleshooting the massive machine by listening to its rhythmic pulses. Thomson, an African-American pioneer, transitioned from operator to programmer at SDC, breaking barriers. Next, we explore the Silicon Revolution, tracking the journey from Fairchild Semiconductor to the modern microprocessor. Fairchild Semiconductor, founded by the traitorous Eight, was the industry's mitochondrial Eve. A culture clash with East Coast management, who didn't understand the stock option culture, led to a diaspora. This talent exodus fueled giants like Intel, AMD, and LSI Logic, shaping Silicon Valley. Federico Fagan, the soul of the chip, was the Intel architect who led the design of the first commercial microprocessors, the 4004 and the 8080. He founded Zilog in 1974 after leaving Intel. Fagan created the Z80 and pioneered the fabless model of chip design. Chuck Peddle created the cheap 6502 chip for just $2, making it 10 times cheaper than Intel's offering. This chip powered the Apple II, Commodore 64, and NES, sparking the personal computer explosion and democratizing computing through distributed intelligence. We move on to the mini-computer era, focusing on Route 128, DEC, and the East Coast giants. Mary Allen Wilkes is known as the first PC user. She worked on the Link, arguably the first personal computer. In 1965, she installed a Link in her parents' living room to write code. Wilkes developed LAP6, an interactive operating system, breaking the punch card paradigm. Next, we explore Xerox PARC, often called the Laboratory of Dreams. Xerox PARC invented the future with the Alto, the first computer with a GUI, mouse, and bitmap display. Bob Taylor led the Dream Team. Bob Metcalfe invented Ethernet to connect the Altosies. However, Xerox failed to productize its inventions, leading to an exodus that fueled Apple and Adobe. We now look at the rise of Apple, shaped by wizards, visionaries, and conscience. The Macintosh team included key individuals like Bill Atkinson, who created QuickDraw and HyperCard. Andy Hertzfeld was the architect of the Mac Toolbox. Joanna Hoffman was the marketing lead and the team's conscience. The next chapter focuses on software and artificial intelligence, tracing the evolution from syntax to neural networks. Key architects of syntax include Donald Knuth, Ken Thompson, James Gosling, and Bjarne Stroustrup. They pioneered advancements in typesetting, text encoding, portability, and system efficiency through languages like TeX, Unix, Java, and C++. The internet was built by architects like Kahn and Cerf, who designed TCP/IP, and Bob Metcalfe, who scaled Ethernet. Implementers like Judy Estrin co-founded Bridge Communications and built the physical boxes that moved packets, consolidating the industry. General Magic, the Pocket Crystal, was a visionary failure. They spun out of Apple to build a smartphone 15 years too early. The concept included a handheld device with a touchscreen, apps, and AI agents. Though it failed commercially, its alumni built the iPod, Android, and eBay. The digital age was not inevitable. It was willed into existence by individuals who refused to accept the world as it is.